Okay, we are continuing with section 6.5. We are now doing roots of a complex number. So we have two examples. The first one says find the eighth roots of 1. So the first thing I'm going to do is I'm going to make this into a complex number and have it as my z. So z is equal to 1 plus 0i. If I were to plot that, that would put it on the x-axis right about there. Okay. So we need to first convert this to a trig form. So I need to find my r and I need to find my theta. So r, remember, is the a squared plus the b squared from my complex number. So that's going to be 1 squared plus 0 squared. And that's just going to be 1. My theta is my inverse tan of the b over the a. So in this case it's tan to the minus 1 of 0 over 1. And that gives me that theta equals 0. Why did I write a theta? Alright. I probably could use 2 pi, but 0 is just really easy to work with, so we're going to just leave it as 0. Now, looking at the formula, I've written it on the page here to the right. We are going to be doing, since we're doing the eighth roots, our n is equal to 8. Okay? So we're going to be doing the eighth root of r times the cosine of theta plus 2 pi k over n plus I sine of theta plus 2 pi k over n. And again, n is going to be r is 8 because we're looking for the eighth roots. The only other variable we have is k, and this is where the changes come from. K is going to be the values starting at 0 to 1 less than our root. So we're looking for the eighth root, so 1 minus 8 is 7. So k is going to be from 0 to 7. And that's going to give us all of our roots. So that means we have to do this till we're done with all our k values. And it's just repeating the same process over and over. Alright? So really all we have to do right now is we just substitute in values. And I'm going to do it down a little bit because it does take up some space. So let's do the first one. I want the eighth root of r, and r was 1, times the cosine of 0 plus 2 pi, and we're going to start off with k of 0, divided by 8, plus I sine of 0 plus 2 pi 0 over 8. Simplify that. Well, the eighth root of 1 is just 1. The cosine of 0 plus 2 pi 0 over 8, well, that's just the cosine of 0. So that's 1. Plus I sine of 0 plus 2 pi 0 over 8, well, that is just sine of 0, and that is a 0. Okay, so we basically have 1 plus 0, and that's 1. So there's my first root. And we're just going to repeat this process all the way down till we get to 7. Eighth root of 1, cosine of 0 plus 2 pi. This time that k changes to a 1 over 8, plus I sine of 0 plus 2 pi times 1 over 8. Okay? So the 1 stays on front, so I'm just not going to necessarily put it there anymore because we know 1 times anything is that. And if I look inside here, these are going to be the same. So if I simplify them, they're the same value. 0 plus 2 pi times 1 is just 2 pi over 8 is pi over 4. So really what I have is the cosine of pi over 4 plus I sine the pi over 4. Well, pi over 4 is root 2 over 2 plus I sine of root 2 over 2. Okay, so there's my second one. Let's go on to the third. Eighth root of 1 cosine of 0 plus 2 pi times 2. So I'm just going to, 2 pi times 2 is 2 pi, excuse me, is 4 pi over 8 plus I sine of 4 pi over 8. So there's a few ways that you can kind of streamline it, because you can notice, especially, that's why I said I wanted to start with 0, things are a little easier with that. Well, 4 pi over 8 is pi over 2, the cosine of pi over 2, plus the I sine of pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, so I just get I. Okay, there's the third one. Let's go to 4. We're halfway done. Eighth root of 1 times the cosine of, this time now it's 2 times 3. So 0, so if you remember where we're at, 0 plus 2 pi times 3 over 8. So this is going to be I sine of 6 pi over 8. Well, let's see. 6 pi over 8 is 3 pi over 4. So the cosine of 3 pi over 4 plus I sine of 3 pi over 4. Cosine of 3 pi over 4 is negative root 2 over 2. Sine of 3 pi over 4 is just root 2 over 2. Okay. Hey, we've got 1, 2, 3, 4 roots. 3 more to go and we're done. Keep going. The thing about this is it's patterns and keeping track of where you're at. So we have 0 plus 2 pi times 4 over 8 plus I sine of 2 pi times 4, which would be 8 pi over 8. Okay. 8 pi over 8 is just 1 pi. So that's the cosine of pi plus I sine of pi. Cosine of pi is negative 1. Sine of pi is 0. So negative 1 plus 0 is just 0. Or excuse me, negative 1 plus 0 is just negative 1. Okay, we're up to 5. Eighth root of 1 times the cosine of 2 pi over 5 over 8 plus I sine of 2 pi times 5 is 10 pi over 8 equals 10 pi over 8 is going to be 5 pi over 4 plus I sine of 5 pi over 4. Cosine of 5 pi over 4 is negative root 2 over 2 minus I times root 2 over 2. Okay. Almost done. Now you're probably saying, well, I'm noticing a pattern. Oh, the first one was 1, and then the next one we had, both were positive with root 2's over 2's, and then we had I, and then the first one was negative, and so forth. That's what we're working. There is a pattern, but you still need to kind of work these out just to make sure you're getting it. Alright, eighth root of 1 cosine of 2 pi times 6 over 8 plus I sine of 2 times 6 is 12, so it would be 12 pi over 8. I'm just kind of streamlining it a little bit. 12 pi over 8 is 3 pi over 4. Oh, excuse me, 4 pi over 3. I'm sorry, 4 pi over 3. So the cosine of 4 pi over 3. No, what am I doing? It's not 4 pi over 3, it's 3 pi over 2. Plus I sine 3 pi over 2. Well, cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1, so that just makes that negative I, so my answer is negative I. Okay, last one. Alright, so so we need the 8th root of 1, and we're on that last one. So 2 pi times 7 over 8 plus I sine of 2 pi times 7 over 8. And that's going to give me, 2 pi times 7 is 14 pi over 8. That's going to end up being 7 pi over 4. So the cosine of 7 pi over 4 plus I sine of 7 pi over 4. 7 pi over 4 for cosine is root 2 over 2 plus sine of 7 pi over 4 is negative, so negative I root 2 over 2. And there's our last root. If we had gone one more to 8, if I did one more, I would have got 16 pi over 8, which reduces to be 2 pi, which is the same as a 0, which is what we started with. So basically it's just working its way all the way around the unit circle. Alright, so that's the first example. Let's move on to the second. Okay, so this time we're finding the 5th roots of negative 9 root 3 over 4 minus 9I over 4. So that means my n is equal to 5, and k is going to be 0, 1, 2, 3, and 4. So not as long as the last one. So the first thing we still need to do is we need to find our r, and we need to find our theta. Okay, so r is going to equal the square root of the negative 9 root 3 over 4 squared plus negative 9 over 4 squared. So if I square the first one, I'm going to get 81 times 3 over 16, so that's 243 over 16 plus 81 over 16, and it gives me the square root of 324 over 16. Well, 324 is a perfect square, so that becomes 18 over 4, which just reduces to be 9 over 2. So there's my r. Now to find theta is inverse tan of negative 9 fourths over negative 9 root 3 over 4. Okay, so the 9s are both in the numerators and the 4s in the denominators. Those are going to cross out. And that's going to actually leave me tan to minus 1 of 1 root 3. Well, that simplifies to be just root 3 over 3. So now if I look at this, my original graph, both the A and the B were negative, so that's in the 3rd quadrant. So there's somewhere down here. So that means my theta has to go all the way around. So tangent's in the 3rd quadrant, and it's root 3 over 3, so that would tell me that theta equals 7 pi over 6. Alright, let's do our roots. So we're going to do the 5th root of 9 over 2. And you're probably thinking, how do I do the 5th root of 9 over 2? Well, you just do it this way. 5th root, 9 over 2. You're not going to have to simplify that. The cosine of my angle, which is 7 pi over 6, plus 2 pi, and this time k is 0, so it's times 0, all over n, which is 5, plus I sine of the same thing, well, if I look at this, this is not going to be on my unit circle because I'm going to get 7 pi over 30. So I can actually just rewrite it as that. And I can use my shortcut. So I can rewrite this as the 5th root of 9 pi over 2 cosine of 7 pi over 30 plus I sine of 7 pi over 30. And if I didn't want to go through all that, I could just rewrite it as 5, 9 over 2 CIS of 7 pi over 30. Okay? So we're going to be able to use our shortcut this time. There's the first one. Let's do the next one. Fifth root of 9 over 2 of our cosine 7 pi over 6 plus 2 pi, this time k is 1, over 5. Alright, and that's going to equal the 5th root of 9 over 2, and I'm just going to use my abbreviation here because this, again, is not going to be on my unit circle. Well, if I want to simplify the 7 pi over 6 plus 2 pi divided by 5, well, I'm going to do 7 pi over 6 plus 12 pi over 6 divided by 5. That's going to give me 19 pi over 6 divided by 5, and that's going to end up being 19 pi over 30. So I can just put that here. Okay, now we're on to the third one. Same thing. 5th root of 9 over 2 times the cosine of 7 pi over 6 plus 2 pi times 2 all over 5 plus I sine 7 pi plus 2 pi times 2 over 5. Alright, same thing this time. It's going to be 7 pi over 6, but instead of 12 over 6, it's now going to be 24 over 6, because 2 times 2 is 4, divided by 5. 7 and 24 is 31 pi over 30. So now we're going to have that 5th root of 9 halves CIS of 31 pi over 30. Now if you look at this, you can look at our angles. Our final angles, the first one was 7 pi over 30, the next one is 19 pi over 30. That increased by 12 pi. Add another 12, and I end up with 31. So there is a pattern to this, so you can check your work as you go to make sure you're doing it correctly. Okay, 2 left to do. 5th root of 9 over 2, and I drew that a little too high, so let me just write it a little bit lower. Times the cosine of 7 pi over 6 plus 2 pi times 3 over 5 plus I sine 7 pi over 6 plus 2 pi times 4, or excuse me, not 4, times 3 over 5. Alright, same thing. I have that 7 pi over 6 plus 2 times 3 is 6, times 6 is going to be 36 pi over 6 divided by 5, and that gives me 43 pi over 30. So now I have my root, fifth root and 9/2, CIS, 43 pi over 30. And is that 12 more than the previous? Yeah, it is. Let's keep going. The last one. Almost done. We want the fifth root of 9/2 times the cosine of 7 pi over 6 plus 2 pi times 4 all over 5 plus I sine of 7 pi over 6 plus 2 pi times 4 all over 5. Okay, so let's add our angle together. So we have 7 pi over 6 plus, this time 2 times 4 is 8, 8 times 6, so that's 48 pi over 6 divided by 5. 48 plus 7 is 53 over 30. So 9, excuse me, not 9, fifth root of 9/2, CIS of 7 plus 48 is 55 pi over 30. And this one reduces. If you look, I can divide both by 5, so we need to reduce that. And I get 11 pi over 6. Uh-oh, that one's on our unit circle, so we can actually simplify it a little more. So we're going to actually have to do the cosine and the sine of this. So the cosine of 11 pi over 6 is root 3 over 2. Plus, or excuse me, the sine of 11 pi over 6 is negative 1/2. Okay. So we can leave it like that. Or likelihood is you can do it either way. Alright? So that's it for this example. If you have questions, make sure you come to class with them.